Hey, the average Joe here. Hey, a couple years ago, we had Jerry Rig Everything and his family move in just around the corner from our home. My grandkids couldn't believe it. He was in our neighborhood. Well, if you haven't heard of Jerry, today is your lucky day. And if you take the time to look at some of his amazing videos, you're going to be very well educated and entertained at the same time. Jerry has just under 9 million subscribers and thousands of videos on YouTube. The one video we're going to talk about today is his underground bunker in his backyard he just installed. Jerry recently gave a tour of this bunker to me and others in our neighborhood. So today we're going to show an HVAC design created by the software HVAC solution that could be utilized in this type of a project. And as Jerry says in his videos, so let's get started. What I'm pulling up here next is a SolidWorks drawing of what he created for his bunker. There's two pipes that he welded together here in the middle, and over here to the right you'll see an actual picture of his excavated hole in the backyard. And then he's got a structure here on this left hand side. That's where he put an elevator, a scissor lift elevator, and a ladder to get down. And then on the other side he'll have a ladder and an entrance exit, two ways into that bunker. The whole bunker looks like it's going to sleep 6 people down in there. Now, right at the bottom there, inside there, you can see he created a floor, and that's the structure of the floor, and then he'll put a flooring over top of that. But in our drawing that we're going to show you and go over, I've kind of showed the system being installed down under in this area under that floor. Some of the equipment could be located in these two end rooms in the bunker as well. So here we have the software. I took the liberty to use our little drawing toolbar feature over here on the left and show the dirt around the underground and around the bunker. It has access, like we talked about, on each end. A little solar collector at the top with the sun shining on it to get him power down in there for his TV and his other electronic devices. So continue on his videos down there. Over here, we've got the master bedroom, and then the bunk bed area for some kids. And then out here, Jerry Riggs in his living room there. And then there's a kitchen over here, and there's a bathroom over here as well. Now, I've shown on this drawing, we want to bring some fresh air down into the bunker. So I have a hood shown up there. Blue is the color of the software that we have for outside air. That air's coming down the area where the access ladder comes down into through a duct into a fan, and then that air is going to go through the system, air-to-air heat exchanger, through some filtration, MERV 13, carbon filtration, and then come in, and in the floor we'll put some grills to supply air into these spaces. Now, the way I laid this room out, this system out, was to get some air into the master bedroom, the kids area, and then the living area, and then have this air transfer through either grills or openings under the door, cracks, and have it air work this way. I'm going to zoom in here a little bit, and you'll see positive. This air in this room is positive, and the air is flowing out. So it's flowing this way. Some of the air is going to be exhausted out the kitchen and the bathroom area, but the other air in this room, I've actually had it, and I can click on this space, and these green grabber dots is the extent of that space. And if I double left click on it, I can see the amount of air that I put in that, temperatures, BTU, heat gain, other exhaust that might be in that area, and other things associated with the summer cooling and winter heating. And then the air in this space, we want to make this positive, right? And we want that air to flow out into this area and be exhausted out of that area, and then this area as well. And that's the green ductwork with all the ductwork sized going out in the system. So as you model, a system in HVAC solution, it's going to do all the calculations, select equipment, and then schedule it so the contractors can, build it and bid for that as well. Let's look at the design a little closer here. The air's coming down, and you'll see there's 100 CFM, and we have 4.71 inches of static. Now that's what this fan has to overcome to get the air through the heat exchanger. Let me just come down here and kind of show you what that looks like in detail. Fresh air coming out, coming through, and this, the air inside is going to be exhausted out, and there's a transfer of that air, so we're going to pull some of the heat out of that in the wintertime, some of the cooling out of that in summertime, and then that air is going to come into space, and the air is going to go out. Now these ventilators many times have fans on them. These fans and the static, you've got to have enough static pressure to overcome everything that's in that system, and that's what I put this little fan on here. I could delete that fan, but I wanted you to see the CFM and the static pressure. And if I click on that fan, I can go in and look at that internal, external static pressure of that fan that it sees in the system. It sees those filters, it sees dampers, the hood, there's a little loss around inlets and outlets, and then ductwork. There's a loss in there. If I come over here, every one of these components is intelligent and smart. If I click on this MERV, if I change it from dynamic to something else, you'll notice that MERV ratings, these are all the MERV ratings. The higher MERV you go, the greater the pressure drop's going to be to start off with, and then when that's dirty as well. But I picked this dynamic MERV 13. That's a pretty good filter for that. And then over here we showed a carbon filter to get out other contaminants as well. And you'll see the pressure drops on that. Now, if I happen to delete that carbon filter and delete this MERV, you'll see now I'm going to be down to, my static pressure is going to go down to 2.5 inches. And that's going to be mostly the pressure drop through this heat exchanger to come in and to get out of this system. Higher pressure drop right in the system, and the greater the CFM, the higher the horsepower, the more power it's going to use, obviously, in the system. Now, if for some reason we needed more heat in the system or the space, I could come up to my toolbar, I could go over the air here, I could come over and say, well, I'd like to put an electric heating coil in that and drop that heating coil in there, and then start looking at the temperatures that might take place on that. So this is just a nice little simple project showing the airflow, showing how it's going from positive pressurization to the other spaces. Now, the other thing we get from the software file, coordination file options, would be lots of different coordination reports. So here I want to see my bill of materials, controls, no, electrical, no, I want to see equipment schedule. So I have those both checked. I'm going to save this project. I'm going to come to File, Open, and now we want to look at that bill of materials for this project. This is where a contractor can take and look at this drawing, and then he can go to a supplier and say, hey, how much do these dampers cost? I need this much duct work. Here's my fan, here's my filters, grills for the project. You can do the cost estimation in the software. You can do it just in Excel or work with a local supplier or whatnot on that. And then the other schedule that's important on a project like this would be the equipment schedule. Equipment schedules and the drawing is usually what goes on the project with like a Revit drawing, right? A Revit drawing is going to show it in 3D and make sure it's going to fit in that space. So here you'll see the project, my temperatures that I have in the winter and the summer, different, well, that's the coil I put on. I need to take that off. Dampers. Here's my energy wheel, fan tech. There's the grills, Titus grills, supply, what they are, different things about the hoods. I want to come over here and show you the space. So the space is where it's going to show each space, and I could have labeled them on here what they were. And then what areas of the spaces serve, the CFMs, the temperatures, whether it's negative or positive pressure in that space. I can double left click on my white screen here and go in my notes, description and right below that, change. These are my temperatures, winter and summer of Salt Lake City, Provo, Utah area. Kind of we're down in the Highland, Lehigh area, and this is the temperatures that we use in this area. Obviously, if I want this design in another area, I'd go in and change the weather data to that area where I'm going to design that project. Hey, hope this has been helpful and useful for laying out a system or a project. It's a simple system that needs some outside air ventilation with a heat exchanger, in this case of the bunker that Jerry created in his backyard. I also include the video of this in my email, so you can click on that and see his actual video of him going through the process of his bunker creation. Hope this has been helpful. Hey, thanks for watching.